Okay, so this lab is the index of refraction, and if you remember from the notes, refraction is the bending of a wave as it enters one medium to another. In this lab, the media will be air and this acrylate piece of plastic. Looks like glass, but it's very clear plastic. Okay, so what you'll do, this is the lab you'll need, and you'll follow the instructions on one side and then do the lab on the other. Okay, so you take the block, actually I'll be doing the lab on the other, and you set it on the rectangle, and then you'll have a 30-degree angle coming in about 3 centimeters from the one side. And then what you're going to do is you have to sight down at table level to pick up this line. So I'll put my pencil right here so we can clearly see it. And then if you'll come down with me, and I put the ruler to basically become an extension of that line. So camera person, can you see the edge of the ruler?
Yep.
Is it lined up with the line?
Not quite.
Not quite? Okay.
Rotate a couple of degrees west.
I'd say right about.
Yeah, west. Yep, there you go.
Okay. Then, if we continue this line to where it meets the plastic, you can see that this line is not contiguous because the light bent as it came through the plastic. So then what we have to do is mimic that with this.
So why isn't your ruler bendy?
Haha. Because rulers don't refract. And then we need a normal on this side. And so the angle of incident, angle of refraction is on the other side of the normal. So this is the incident angle, this is R, the refracted angle. Then this is the incident angle, this is the refracted angle. So think to yourself, what angle should this be compared to this angle? And if you see, those lines are definitely parallel. So if we measure this angle, we can see that it's 30 degrees. Okay, then I just need to measure the refracted angle, and I see that it's 19.5 degrees. Now, I forget, is that Celsius or Fahrenheit? Ha, ha, ha. Oh wait, this is angles. So now, if we come to the front side, and I was 30 degrees, R is 19.5. So the way to find the index of refraction is to take the sine of I over the sine of R. So if we can pause it and calculations, and then we'll do another drawing. So ready when you are. Say ready. Oh, okay. So we have our angle of incidence, angle of refraction. The two ways of figuring out the index of refraction are with the velocity in air versus the velocity in the media. But we don't have anything that can come close to measuring those. So another alternate way is by taking the sine of I over the sine of R. So I calculated the sine of I at 0.5 exactly, and the sine of R was 0.33378 something, so I rounded it up to 0.334. When you divide those two, you get 1.497, and the accepted value is 1.50. So if we take that minus 1.5 equals divided by 1.5, we get
Times 100.
0.19%. Pretty good. Actually, that'd be 0.20%, wouldn't it? Now, we're going to do this again with a more extreme angle. So I have the angle already drawn. And if I take my piece of acetate and line it up, and then come the line on the other side. It's way up here.
You need your pencil.
Okay, so for you to see it, you're going to want to bring the camera right in line with that. And then you can see the line lines up with the ruler.